In this section, we're going to integrate parametrically defined curves. And the key thing to remember is that if you want to work out the area underneath a curve, say we've got a curve that looks something like this, between the limits of x equals a up to x equals b, in order to work out this region here up to the x-axis, then we would work out the integral with limits of x equals a and x equals b of y with respect to x dx. And y would normally be given to you as an equation in terms of x. So you might have, for example, y equals x squared plus 1. And you would just sub that in instead of y. So we want to work out the area of this region here between x equals 0 and x equals 2. So I'm actually going to ignore the fact that I don't know what y is in terms of x. I'm going to ignore the fact that it's a parametric curve, and I'm just going to say, well, I know that that's going to be the integral from x equals 0 up to x equals 2. And we want to integrate y because we want the area underneath y with respect to x. That's our formula for area. Well, if I look at the equation of y, I've been given it, but it's got a t in it. So let's just substitute in that value of y there. So 1 over 1 plus t. And we've still got dx on the end, and our limits are still from x equals 0 up to x equals 2. So this is kind of like the integral you get when you do a substitution. We've got a mixture of t's and x's. And we want to eliminate the x's to get it as an integral in terms of t. So we know that what we need to do is we need to replace dx with something to do with dt. And in order to do that, we're going to differentiate x with respect to t. So if we look at our equation of x, if we multiply it out, we're going to have t plus t squared. So we can work out dx by dt is equal to 1 plus 2t. So if I rearrange this equation to get dx the subject, just like we would do with a substitution, I find that dx is equal to 1 plus 2t times dt. I've just times both sides of this equation by dt. So that tells me that I'm one step closer to getting this as an integral in terms of t, because I can replace dx with 1 plus 2t. Now, the final step that I need to do is I'm going to change the limits to t limits. So at the moment, I've got limits of x equals 0 and x equals 2. So I need to work out what is t equal to for each of these values of x. So when x equals 0, let's do the lower limit first. I know that using the x equation here, I know that 0 would be equal to t plus t squared. So I could factorize that. In fact, it was already given in factorized form. So we get two solutions, either x is 0 or either t is 0 or t is minus 1. Well, we've got this condition here which helps us out. We're told that t is greater than or equal to 0. So if I look at these two solutions, t equals 0 or t equals minus 1, I know that it's not t equals minus 1. So that means that I can replace the lower limit with t equals 0. They're equivalent to each other. And similarly, with the top limit, when x equals 2, I know that 2 is equal to t plus t squared. So 0 equals t squared plus t minus 2. So we've just got a quadratic here, and this has solutions of t equals 1 or t equals minus 2. And again, we know that t is greater than or equal to 0. So we know that t equals minus 2 isn't a solution. So we can put that top limit as t equals 1. So now we've achieved our aim. We've got an integral which is just in terms of t. And we just got to try and work out how to integrate this. So it might not be exactly obvious how to integrate this. You could try substitution. You could try u equals 1 plus t and turn it into a du integral. Or you could do partial fractions. So I'm going to do partial fractions in order to solve this, but you could try it with this substitution as well. So with partial fractions, I've realised that this is an improper fraction. And that means that I need to start with polynomial division. So you can use your favourite method for polynomial division, but I'm going to do long division to start with. So I want to do 2t plus 1 divided by t plus 1. So I'm going to ask myself, what do I times t by to get 2t? 2, and then times everything on the outside by 2. And then I need to do the top line take away the bottom line. So 2t take away 2t is 0t, 1 minus 2 is minus 1. And remember, this is our remainder. So this tells me that I can write this fraction, 1 plus 2t over 1 plus t, as 2 minus 1 over 1 plus t. Because remember, the remainder goes on top of the fraction. So let's replace that fraction with that. So we've got 2 plus minus 1 over 1 plus t. And we've got limits of 0 up to 1. I'm not going to keep on writing t equals 0 up to t equals 1 because we know that everything's in terms of t. So integral of 2 is straightforward. That's just 2t. And if we integrate this, we're going to have minus natural log of 1 plus t. If you can't just spot that integral, then you could, if you wanted to, write that as the integral of minus 1 over 1 plus t. And if you really wanted to, although I wouldn't recommend it, you could use a substitution. You could say let u equal 1 plus t, so that du by dt is equal to 1. So that means that du is the same as dt. So then the integral would be the integral of minus 1 over u du. And we know that 1 over u integrates to log u. So we'd have minus log of u. So now we just need to sub in our limits. So if we sub in the top limit, we're going to have 2 times 1 minus natural log of 2. And we need to subtract what we get when we sub in the lower limit. If we sub in the lower limit, we're going to have 2 times 0 minus log of 1. And here we've got 2 minus log of 2, and everything in this right hand bracket is 0. So we get our final answer.